continue with 6.1. So 6.1 was number theory. We talked about prime numbers. So a number is prime if its only two factors are 1 in itself. We talked about the divisibility test. I think that these are super helpful, right? And I think somebody asked how, if I have a calculator, why do I care? And here was the example. This is why we care. Then we stopped with the fundamental theorem of arithmetic. So every natural number greater than 1 can be written as a unique product of primes. And we said it was unique because 2 times 3 is 3 times 2. That's a property of numbers that we kind of take for granted. Okay? So let's continue. So the directions are factor. This was example 1. Example 2 is 600. Factor 600. Okay, so I factored it. 600 probably don't need a calculator for, right? Okay, so then these are my factors. Right, whatever's at the bottom of the tree, those are the factors. And you guys know the definition of exponents, right? Like 2 squared is 2 times 2. So let's write that. 2 times 2 times 2, that's 2 cubed. Times 3 times 5. I have 2 5s, so that's 5 squared. So that's me factoring 600, right? How many of you guys are thinking about going to graduate school? I know you might just be freshmen, but... One person? 2 people? So, okay. So a lot of this math does show up on the GRE test. Do you guys know the GRE? If you're going to apply to graduate school, you need to take the GRE, which is the general standardized test for graduate school. And there's like an...
Another test?
Huh?
Take another test?
To get into graduate school?
Yeah.
Yeah. Typically, you have to take the GRE. If you're looking to go to graduate school for a certain subject, then like there's a math GRE, which tests your knowledge of all undergraduate math classes, or there's like a biology GRE. Just like if you want to go to medical school or law school, there's specialized tests for those things, right?
I was going to ask, if you want to go to law school, you have to do this.
If you want to go to law school, I think you need to take the general GRE, and I think you need to take the LSAT. The LSAT is the standardized test for law school.
Okay.
But the general GRE there's like a vocab section, there's an essay section, and then there's a math section. And a lot of this math does show up on there. I have a student who was in Math 135 last semester, and I'm helping her. She comes to my office hours, and we do GRE stuff. So this is on there. All right, another example. So factor 540. What's the easiest thing to see that this is divisible by? 10, right? Because it ends in 0. So it's 10 times 54. Those are easy numbers to deal with, right? What's 10? 2 and 5. What's 54? What is it? 9 and 6. What's 9? 3 and 3. What's 6? 2 and 3. Okay, so let's write that nicely. So write it as 2 to a power, 3 to a power, 5 to a power. What did you guys get? 2 squared. What? Times 5. 3 cubed times 5. I just do it in order. It doesn't make it right or wrong, but doing the powers makes it nicer to look at, right? And I'll box it. Okay. So we know how to factor. We'll have the dollar calculator so that we can say divided by whatever, right? But you should look at it and kind of know, right? Like, oh, this is divisible by 9. 5 plus 4 plus 0 is 9. It's divisible by 3, right? The sum of the digits equal 9, which means it's divisible by 3. So you should have some idea, so you're not just going pressing crazy buttons on your calculator. Okay, so we could do a million examples if we wanted to, right?
On our homework, are we going to have to convert it from
You are going to have to factor.
So is that, these are, what is it called?
Factoring?
Factoring? You have to factor to the regular number.
You're going to have to multiply this out to equal this?
Yes.
I mean, if you wanted to.
Okay.
But I think it's usually done this way. To find the prime factors, write it as the prime factors.
Okay.
So the next topic is the greatest common factor. Greatest common divisor. Greatest common divisor. And so that's GCD. And the least common multiple. Least common multiple. Okay, so that's the next thing we're going to talk about. So let's do a definition. The greatest common divisor, or GCD. So I usually underline what we're defining, right? Or GCD of two natural numbers. What's a natural number again? Counting numbers, good. So 1, 2, 3, 4, 5. I'm not saying 0 and I'm not saying negative numbers. It's positive whole numbers. Numbers is the largest natural number that divides both numbers. Okay, so the greatest common divisor is the largest natural number that divides both. So let's do an example. Or let's write out how to find it. So to find the GCD, we take the common prime factors. That is we multiply the prime factors to the smallest power that appear in the prime factorization of both numbers. Okay, so let's do an example. So the directions are find the GCD. So this is number 4. So GCD of 600 and 540. So this is asking you to find the greatest common divisor between these two numbers. Okay? You guys hang on a second. I'm sorry. My daughter's sick and my husband just texted me. Okay. Sorry, my kids are sick. Okay, so this part right here tells us how to find the GCD. Okay? So to find the GCD, we look at the prime factors of both of the numbers. So we're going to write out the prime factors, and we're going to take the smallest power that appears in both. So let's just smallest power that appears in the prime factorization of both numbers. That's what we're looking for. So recall 600 and 540, we already did the prime factorization. We already did that factor tree. So 600, who can tell me what that prime factorization was? So I want the prime. 10 is not prime, right? So we wrote 2 to a power times 3 to a power times 5 to a power times
2 to the second, 5 to the second, and 3.
For 600? 2 to the third. 2 to the third times 3 to what power? 5 to the second. So this is 3 to the first power, right? What about 540? I'm sorry. Thank you, Ryan. Okay, so now I'm going through. I've had the prime factorization of each. I'm looking for the smallest power that appears in the prime factorization of both. Okay? So I have 2. What's the smallest power that appears?
2 to the second.
Squared. Okay? I have 3. What's the smallest power that appears? 3 to the first, right? I have 5. What's the smallest power that appears? 5 to the first, right? 5 to the first, 5 to the second. I'm writing down the smallest power that appears. So this is my GCD. My greatest common divisor. So it's 4 times 3 is 12, times 5 is... So it's 60. So that's the largest number that divides both. That's the largest number that divides both. Largest natural number that divides both. Okay, let's do another example. Number 5, GCD of 20 and 24. So we didn't factor these ones yet, right? So the first thing we need to do is we need to write down the prime factorization of both of them. So 20, make a little factor tree, and 24, make a little factor tree. Write down the prime factorization of 20 and the prime factorization of 24. So what is 20? 10 times 2, what's 10? 2 times 5. So how can I write 20? Good, thank you. All right, and then what's 24? 6 times 4, good.
I was gonna,
Hey, whatever works. If you want to do 3 times 8, go for it. Whatever you start with doesn't matter. What you end with is what matters.
So what I have, I'm just curious if it'll work, is 12 times 2.
Yes.
That'll work too.
Yeah, because that's correct, right? And then you can split 12 into stuff, and you keep 2. All right, so 6 is 2 times 3, and 4 is 2 times 2.
So 2 cubed times
2
3.
cubed times 3. Good.
Now we have to use every single number right, the GCD.
So let's go through and read what we just wrote again. So the GCD is the largest natural number that divides both. And what I underlined in that way to find it is the smallest power that appears in the prime factorization of both. So I'm looking for the prime factors that are in both, and I'm taking that to the smallest power.
So just 2.
So I have 2 is in both, 2 squared. 3 is not in both, so I'm not looking at that. 5 is not in both, I'm not looking in that. So if you're thinking about this in terms of factors, it would be the intersection, right? It's what's in both, this and this. So the GCD equals 4. So this equals 4. So this kind of tells us the process to find it. How do you guys feel? Is it okay? All right, let's do the last one as a quiz. You guys all get it. Let's do it quick. So take out a blank piece of paper. Put your name on it. I'm looking for the GCD. All right, it's going to be a quiz. You can keep your notes open if you want to. It's hard to learn a definition right now and then apply it right now. So you can keep your books open, but everybody get out a piece of paper, write your name on it, but then once I write it down, there's no talking. It's a lax quiz, but it's still a quiz, right? All right, so we're looking for the GCD between 66 and 110. So when you're answering that, I want all this written down. Show me. You should be able to factor 66, and you should be able to factor 110 without a phone. If you have a calculator, you can use the calculator.